Hi Bhuvneshwari.
Hi, ma'am.
Can you briefly introduce about yourself?
Yes, ma'am. Hi, ma'am. I'm Valuboju Fani Bhuvaneshwari. I'm from Hyderabad. I have completed my graduation in Mahatma Gandhi Institute of Technology. I'm very enthusiastic and self-motivated electronics and communication engineering graduate with strong desire to VLSI design and verification. I have also obtained specialized training of Verilog and digital electronics at Provilogic. During my academics and training sections, I have obtained hands-on experience on Verilog and digital electronics, and I have done my projects on LFSR and MIPS processor. I'm also a quick learner with problem-solving abilities. I'm now looking for a forward-thinking VLSI organization where I can contribute my skills and learn from the industry experts.
Okay, that's great. So, have you done any projects in VLSI in your curriculum, like in your college in academics?
No, ma'am. I have done projects on embedded systems such as RFID-based smart parking system, as well as on communication side, which is BER of 3 users NOMA with a QPSK modulation scheme.
Okay. So, why did you choose VLSI as your long-term career?
If we see in our nowadays, we can see that there is a lot of improvement in VLSI technologies. Starting from small devices to the large industries, we use a chip where billions of transistors are integrated and how they work. I was very interested in those, how they design it. Therefore, I have choose this field.
Okay, that's great. So, how did you rate yourself in digital logic design and Verilog HDL?
Uh, I rate about 8 to 9 in digital electronics, whereas in Verilog HDL, I rate myself as 9.
Okay, okay. Let me start from the basics of digital logic design, then we will work with some problem solving skills with the digital and Verilog. Okay.
Okay.
So, can you explain me how the SOC level structure is designed in VLSI with the basic digital blocks?
Yeah, basically SoC is system on chip, which is a cluster of subsystems, and each subsystem is cluster of IPs. What are IPs? You may get a question that what are IPs? IPs are basically a reusable block, and each block has its own functionality. So these are combined and formed a subsystem, and there are many subsystems such as processor units, GPU units, memory units, I/O peripherals, which are interconnected using protocols. These all together combine to form an SoC, system on chip.
Okay, that's great. So why we are learning digital logic design as a basic subject in VLSI?
If you see any of the designs, we consist many transistors as well as multiplexers, encoders. These multiplexers are basically formed using logic gates, digital electronic signals, and many more. So, if you see digital electronics, it contains FSNs, multiplexers, sequential circuits, gates, which are the basis of many VLSI chips. Therefore, we are learning digital electronics as our main subject.
Okay.
Basic subject.
Okay. So to manufacture a chip, what are the flow we need to follow?
There is basically a flow, VLSI design flow, which consists of first specifications, which designer, RTL designer provides us. What are the power requirements or what are the area needed, everything. And coming to next, we go for RTL architecture. Then we code it using Verilog, and then we finally verify it using some simulation techniques. And then we go for the back-end process, which is logical synthesis, and then logical equivalent circuits we obtain. And coming to the layouts, flow planning, and then clock resynthesis, and physical verification, then taping out, actually obtaining the last circuit chip to the market.
Okay. So you are a design verification engineer, right?
Yeah.
So actually you have missed the main point, functional verification. In VLSI design flow, one of the most important, and you are the functional verification, future functional verification engineer. That's what you are learning. So you have missed your main domain. So you need to point out that functional verification. Once we get the 100% coverage in front end, then only we will send the RTL design to the backend
Backend.
process after logic synthesis and DFT design for testability.
Yeah.
After testing the every gate node to node.
Okay.
Okay. Okay, good. Next, coming to the digital, can you explain me what is the difference between latch and a flip-flop?
If you see latch and flip-flop, both are storage, 1-bit storage elements. But the main difference lies in between latch and flip-flop. Latches are level-sensitive circuits, whereas flip-flops are edge-sensitive circuits. The outputs only corresponds only at the edges of the clock, whereas in latches, for every level, the output corresponds. So if we see in latches, the output corresponds to the level. Therefore, there may be glitches. There may be transitions between the 0 to 1 or 1 to zeros, which may arise to race around conditions in latches. Therefore, to avoid that, we enter into the flip-flops, which are edge-sensitive circuits, edge-triggered circuits. The outputs only corresponds to the positive edge clock or negative edge clock. Here, the latches use enable as its signal, main functional signal, whereas clock is used in flip-flops. And that's the basic difference I know.
Okay. How many bits a latch can be stored and a flip-flop?
As I have told, it's a 1-bit storage element. Both latch and flip-flop stores 1-bit storage.
Okay. So, if I want to store 8-bit data or 16-bit data or 32-bit data, like a nibble or a byte or word, then what I need to do with the flip-flops?
We need to cascade the flip-flops or cascade the latches so that we can store multiple bits.
Okay. 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 So, can you explain me what is meant by a counter, the real-time practical applications of counter?
Yeah. Counters are basically circuits which count number of states or number of pulses. There are different types of counters, synchronous counters, asynchronous counter. In those both also we can have up counter, down counter, up down counters. If we see real-time applications, we can use in digital timers. In many of the SOC blocks, we can see counting is basic operation. So we use counters there. Digital, we see that hours, minutes, and seconds can be calculated using counters. 5-bit counter, 3-bit counter, and 5-bit counter. That's all.
Okay. So, can you tell me what is meant by a multiplexer?
Multiplexer is basically a combinational circuit which accepts multiple inputs and produces single output. It's basically a data selector. It is also called as data selector, many to one selector, universal logic circuit, and many more, which I know. Yeah.
Okay. Okay. So, we call as multiplexer is a universal logic circuit, right?
Yeah.
So, how can you justify it? How can we call multiplexer is a universal logic circuit?
Universal logic circuit. We can say multiplexer as universal logic circuit as it is used in many of the blocks, such as in transmissions. If you take it in MIPS processor, which I have done project, each block contains a multiplexer, which can take multiple inputs and cascade it to some output.
Okay. Okay.
That's what.
Okay, fine. Can you design a XOR gate using a multiplexer, 2x1 multiplexer?
Yes, ma'am. Now it's done.
Okay. Can you design the same XOR gate as a NOT gate and a buffer? How it will work?
Yeah.
Can you write a more simplified way? Just using a single XOR gate.
I don't know, ma'am.
Hmm?
I don't know, ma'am. I remember it again.
Okay. uh, Suppose here A is 0. If A is 0, what is the output here?
B. As we have seen, it's similar to B.
Same as B. Whatever there in B, output also getting same. 0 means 0, 1 means 1. So what gate it is?
XOR gate.
Here, if input and output both are same, what is the gate it is? Buffer. So for XOR gate, if any one of the input is ground, the XOR gate will work as a buffer. Here, if any one of the input is 1, then what is the output here?
B bar. Reverse
Inverter. In XOR gate, if any one of the input is 1, this XOR gate will work as a NOT gate. Okay. Next. Coming to the Verilog HDL. Can you explain what is the major difference between initial, always, forever and repeat?
If we see always and initial, both are procedural assignment statements which are used in sequential logic design circuits. Initial is executed only once. It's a non-synthesizable block, whereas always is a repeated block which is synthesizable, which can be used in design as well as test bench. If we see forever, it is also a repeated block, but it is non-synthesizable. It is used only in designs. Sorry, it is used only in test benches. This is the basic difference between always, initial and forever. Coming to the repeat, repeat is also a repeated loop, but for a finite number of times. You can repeat the process of execution. That's what.
Okay. So always is repeated continuous loop. So to terminate that loop, what we need to do?
For always and forever, both are infinite loops. So for termination, we use $finish or $stop simulator directives.
Okay. By using a always block, can you generate a clock by taking on time and off time 5 time units delay?
Yeah, I can.
Just try write a Verilog code to generate the clock.
Using always statement.
Yes. Okay. Okay. So here I want to check it in a waveform.
Yeah.
So what we need to do?
We need to add both of the simulator directives. Those are $dump vares and $dump file.
$dump file and dump file so that we can open the
waveform.
dump. We can dump the file and open the waveform and check it.
Yeah.
Okay. Suppose I want to print it in a transcript or log file.
Yeah.
So what are the statements I can use to print continuously?
There are many simulator directives which can be used. Those are $display, $monitor, $strobe, as well as $write. $display prints immediate values, whereas $monitor displays whenever the input changes are obtained. $strobes only displays when the values are updated. And coming to $write is similar to $display, but there is no new tab statement or new line statement.
Okay. Okay. So here to display the clock continuously, which one is better suitable?
I prefer dollar monitor.
Okay. So by using single dollar monitor, we can print everything. So if we use dollar display,
only one condition is print, that is clock equals to 0, you can obtain it.
One statement, immediately it will be printed.
Yeah.
Okay, fine. In Verilog HDL, can you tell me what is the difference between blocking, non-blocking and fork join concept?
Yeah, blocking and non-blocking statements. Blocking statements are represented by using equals to symbol, whereas non-blocking statements are represented by using less than or equals to symbol. These are basically used in combination logic design, whereas these are used basically, non-blocking statements are basically used in sequential logic designs. Blocking statements stores the updated values, but whereas in non-blocking statements, they do not store the updated values. These are executed sequentially. Blocking statements are executed sequentially, whereas non-blocking statements are executed concurrently, not parallelly. But the result we obtain is similar to the parallel fork join case. If we see sequential execution and parallel execution, sequential execution, the statements are executed sequentially, the delays are added. Whereas in fork join concepts, the statements are executed parallelly. The statement which has least delay is executed first, then the next statement, and then next statement.
Okay. Suppose I want to do a swapping operation.
Yeah.
Okay. Suppose A is equal to 10 and B is equal to 20. After doing the swapping, B should get 10, A should get 20. So which method is mostly preferred, whether blocking assignment or non-blocking assignment?
I basically prefer non-blocking statements because we can write the code in simple manner in a single line. Whereas in blocking statements, we need to include a temporary variable and store it in it and then swap the variables. So I prefer non-blocking statements.
Okay, can you please write a piece of code for swapping the variable? We just need to swap the value from one variable to another variable using non-blocking.
Okay. Now let's start.
Okay. Okay. Can you tell me what is meant by what are the different type of memories are there?
Basically, memory is a storage element where we can store the data from many blocks. There are two types of memories, sequential memories and random memories. Sequential memories are of two types, last in first out and first in first out. Whereas random memories are of two types, random access memory and read-only memory. Last in first out works on storing the data initially and then last in, as the definition says, last in, then it's first out. First in first out is similar to queue. If we go to a ticket counter or any movie tickets, we can see that first person takes the ticket and that person goes out to the movie. It is similar to that. There are temporary storage elements where we can store the data. If we see in many of the electronic circuits or SoC chips, there are two types of blocks, which one is working with high speed and another working with low speed. In that cases, we use FIFO memories, sequential memories, to store the data and then pass slowly to the least few blocks.
Okay. So, can you write a Verilog program for write operation and read operation? Just how can we write the data into the memory and how can we read the memory? Nothing but retrieving the data from the memory, read operation.
Yeah.
2 lines of logic.
Yeah. Only the logic.
Okay. So for FIFO, first in first out means both sides the counter incremented from
Yeah.
0 to till depth.
Depth.
Okay. For LIFO, counter incremented and decremented for read operation.
Yeah.
Okay. In FIFO, we need to follow some conditions to write the data and read the data. Can you explain that what are the conditions we have?
Yeah, in FIFO we see that after the memory is full, it cannot store the data. So we need to mention the condition that it is full, so we cannot store the data. And for empty, if the pointer obtained to the last position, we need to say that the read operation is done and the FIFO memory is empty. These are the two conditions that I have seen in FIFO.
Okay. How can we calculate the depth of the FIFO?
I need to read it again.
Okay, fine. Can you explain me what are the different styles we can write the program in Verilog HDL and which one is mostly preferred?
Yeah, there are different levels of abstraction of writing program. Data flow modeling style, behavioral modeling style, gate level modeling style, switching level modeling style, and structural level. If we see data flow, we directly mention the expression in it. In behavioral modeling style, we write it using two tables. Whereas in gate level modeling style, we use gates to mention the logic, whatever the logic is. And in switching level logic, we use transistor CMOS circuits switching it. And in structural level modeling style, it is also called as hierarchical modeling style, where we instantiate the logic or modules into the single code.
Okay. Okay. So which one is mostly preferred?
Mostly we
In
prefer behavior modeling style. As two tables, we can easily identify the two tables and write the logic to it. Therefore, mostly behavior modeling style is preferred in many cases.
Okay. Can you explain me what is the difference between asynchronous and synchronous circuits?
Yeah.
How can we differentiate in Verilog programming?
Yeah. Asynchronous circuits are basically sequential circuits with similar clock signals. All the flip-flops are activated with the same clock signals, whereas in asynchronous circuits, each flip-flop contains its individual clocks and resets. So in the core, we mention it as positive edge clock or along with the reset, positive edge reset. Whereas in asynchronous blocks, we mention positive edge clocks along with the reset, negative edge reset, whatever the reset may be. The reset depends on the clock in the synchronous circuits, whereas the reset does not depend on the clock in the asynchronous circuits. Both clock and reset are individual. Whenever the reset is activated, the output automatically goes to 0. Whereas in synchronous resets, we see that whenever the clock is positive edge, the reset is also activated at the same time. and the output is also changed at the same time.
Okay.
Yeah.
Okay, fine. Can you tell me what is meant by a protocol in SOC level and what are the different types of protocols are there?
Yeah, protocols are the set of rules that are defined so that two blocks can communicate with each other. So that there are many protocols, serial communication protocols, parallel communication protocols, I2C, UART, and AX, these are all ABB. These are all serial communication protocols, whereas
Parallel communication bus protocols.
parallel communication bus protocols. Whereas coming to the another block of protocols, those are AHP and AXI and USB, PCI. These are fast communication protocols used between fast blocks.
Okay. Okay. So, can you tell me what are the major limitations we are facing in Verilog HDL and why we are moving to the system Verilog?
Yeah, in Verilog we can see that it is perfectly used for RTL design, whereas it does not contain any structured verification concept. Whereas in system Verilog we have a structured system Verilog, verification concept. If we see in Verilog, we have limited data types such as net and register data types. If we come to system Verilog, we contain user-defined data types, four-state data types, logic data types, and many more. If we come to the Verilog, we have static array, which is fixed, which cannot be changed during the runtime. Whereas in system Verilog, we have another two types of arrays named as dynamic array as well as associative array, which can be changed during runtime according to the user's requirement. Coming to the randomization concept. In Verilog, there is no effective randomization concept, whereas in system Verilog, there is an effective randomization concept. The randomization can be controlled by using constraints and ranc methods. Uh, Coming to the another block, in Verilog, there is no concept of coverage as well as functional verification concept and assertions concept. Coming to the system Verilog, we have coverage concept, which is the main concept. What is coverage? You may ask me, what is coverage? Coverage is basically how much percent of the design is covered or verified, and how much data is verified and what is not verified, and how many test cases are failed or passed. Coverage is an important concept to check whether all the test corner case scenarios are verified or not, so that the design is covered 100%. Coming to the assertion is also one of the major concepts in system Verilog, which validates the behavior of the design. These are the drawbacks I have seen in Verilog.
Okay, perfect. Okay, good.